Hello everyone, this video is about Crout's LU decomposition method, which unlike Doolittle's method puts constraint on the upper triangular matrix that all elements on its main diagonal should be equal to 1. The product of the lower and upper triangular is the matrix on the right hand side. The main steps followed remain the same except a few changes. We compute the elements of the lower and upper triangular matrix and store these elements in a mixture matrix. The forward substitution is then performed, and finally we perform the backward substitution to find the solution. If you want to see more details on these steps, please watch the previous two videos in this series. I'll place the link in the description. We then write a function, Crout decomposition, which takes the coefficient matrix and output vector b as inputs. We loop over the rows and columns. If the row index is greater or equal to the column index, we update the lower triangular element, otherwise we update the upper triangular element. After that, we run the forward substitution followed by the backward substitution to get the solution. This is the code for forward and backward substitution. Now let's try to solve our example curve fitting problem with Crout's decomposition method. In the curve fitting code, we again make two changes, one to import Crout decomposition function and other to use this function to get the solution, which is the same as we got in other previously discussed methods. That is, a is equal to 3, b is equal to -2, c is equal to 4. In the next video, we look into Cholesky's decomposition method. Thanks for watching. Please subscribe and see you in the next video.